Back. We are going to have a little bit of technical content and then a little bit of sort of more logistical content. We're going to start off with Avi Friedman, who's going to be talking about NetFlow and the many uses of NetFlow and flow-like data. And then we're going to have Will Charnock come up, and he's going to introduce us to the NANOG board election candidates after Avi is done. So Avi, go ahead.
Thank you. Hello, I'm Avi Friedman, CEO of Kentic, a network analytics company. I used to run operational infrastructure. They try to keep me away from that, mostly are successful nowadays. And how many people in the audience run operational infrastructure? Routers, switches, load balancers, exporting NetFlow, SFlow, IPFix? Okay. How many people use open source flow tools, NFDump, PMAccount, Silk, flow commercial solutions? And how many people have been building their own from scratch on top of big data platforms? So I'll talk a little bit about that. In this talk, I'm going to focus a little bit as a review on NetFlow and the flow-alike protocols, some of the functionality you can do with it. Also talk about some of the other data sources that you might have from the infrastructure, from the customer end, especially some of the people, NANOG's increasingly grown people that run servers, run web properties, and so the infrastructure becomes joined with the kind of operational tools that they're looking to use. Things like web logs, load balancers. How many people enable AVC or IPSLA on Cisco's? So interesting things you can actually begin to get from the infrastructure. When I was running engineering at AboveNet, we had this customer called Akamai turned on. Anyone ever heard of Akamai? And they called me complaining that my unit connectivity was borked, which I could see, by the standard, Mount Sinai, sort of flat top thing. And, all of a sudden I realized here's a customer has better data than our network about we do. And from then on, it's always been an interesting challenge is how do we figure out not just what the network's doing, but what's the performance, what's the impact of it. So sounds like people are familiar with Flow. Anyone ever run a 7206 VXR? Right. So some of the early flow-based routing, awesome, let's do flow routing. That'll work fine until you have forward source address packets, and then you try to, so the early Smurfs and things like that caused issues. But people said, wait, we could get this data out and actually see behind the SNMP, see what's going on. After that came SFlow, which instead of actually putting packets together into flows or sort of sessions, is just packet sampling. And actually, something interesting to think about, SFlow, a lot of router people, usually a lot of people that come from the router world look at SFlow as a switch type thing. A lot of routers can do it. And if you're actually looking at doing DDoS detection, real-time looking at effects of your changes, SFlow is actually an interesting protocol because you can see pretty accurately the effects of what's going on just a couple seconds later. Whereas with Flow, you need to take a minute or two for all the aggregates to come through. And it's also a lot easier on the routers. So if you look at kinds of flow to enable, I would encourage you to test SFlow because it's actually a lot easier to implement. It's just grabbing samples. There's no hash tables and things it needs to associate. So after NetFlow v5, IPFix, NetFlow v9, extensible flow protocols came about. I'll talk a little bit about some of the things that you can do with templated export in IPFix and v9 that can be interesting for operators. But also at the end, I'll talk a little bit about sort of the lifetime and whether these are the right protocols going forward for carrying some of the NetFlow data and also some of the more augmented data. So we'll say flow, we sort of mean all of this stuff. And the way that I think about it is there's the basic flow, which is the 5-tuple ports and IP addresses and protocol, MAC address, VLAN tag, MPLS, all those things that routers and switches can export. And then talk a little bit about augmented flow, which is URL, application performance, network latency, some of those things that some of the other devices can get. Most devices support flow. How many people have blown up a device with flow export related issues in the last year? Okay, so my assertion is it's gotten a lot better than 5 years ago, certainly, right? Inline JFlow, it was out, it didn't work, then no one knew about it, now it sort of works, now you need Samplicator, because it only sent to one place, but basically the devices can export flow, you can get a pretty accurate view of what's going on. We'll save for beer discussion whether you should ever bill based on flow-like data, but from an engineering perspective, it works pretty well. And there's a lot of basic functionality that you can do with Flow, which I'll just do a quick review on. It sounds like people are pretty familiar with that. So again, device export, I would say SFlow where possible for traffic engineering, DDoS detection, but pretty much all of the Flow vendors are familiar with it. You can make it work on Cisco, Juniper, Brocade, Arista, all the Broadcom white box chips, it works. So, state of the flow tools. Um, they all, I would say, pretty much suck to some extent, more or less. In terms of looking at from traffic engineering to availability to performance, being open, having functionality, it's a grind for a lot of people. And we just haven't seen, especially from the ops up to the business intelligence, what's my network doing, the great tool. And there's a lot of people working in this space. The open source tools, NFDump, PM Account, Silk, don't cluster. And this winds up being a scaling challenge for people. Also, some things like BGP, integration, geo, a lot of build it yourself you have to do on top. Um, most of the downloadable commercial software, if you Google NetFlow, is Windows software that also runs on one machine. Some of them have great visualization, visibility, but also similarly not really designed for people that run scalable infrastructure. A lot of the appliances mostly either take the data, aggregate it, and throw it away, or are more security focused. Some of the things that do full forensic, store everything, they don't really want to sell to operators. And then we see a lot of tools groups working with, it used to be Hadoop, now it's more Elasticsearch, but this needs big nodes, tens of servers, and you still have to do a lot of the integration like BGP and SNMP and NetFlow correlation up front. So the key thing as we talk about some of the other sources of data that I'd like to just present is when you look at flow tools, try not to choose a flow package or a flow processing method, or at least when you do, think about some of the other kinds of data that you might want over time. And I'll point to some of the work that Cisco's doing. There's other vendors that are looking at it too, which is what if you had templates coming from Flow that could give you network or application layer performance information? How would your Flow tool store that? So something interesting to think about. So the classic Flow use cases are mostly around traffic engineering, a little bit of DDoS attack, sometimes revenue, who should I be peering with, who should I be selling to. It's looking at congestion, who should I connect to, who am I peering with that I should be selling to. Pretty much all of the politics, the network engineering driven by politics and revenue, you can get some visibility with Flow. Trending, planning, and forecasting. Um, Again, there's even some security use cases of it, not probably as popular in the NANOG crowd, but used in the enterprise. Modeling, how should I adjust the network, and then even customer cost analysis. If you can take communities, suddenly you can look at a packet mile cost on your network and look at profitability analysis from customers. So not going to cover these in great detail, but just to give you an idea, you can take Flow, and again, you think about it, if you've never used NetFlow, done processing, it's looking behind the SNMP. You can see that something is full, but why is it full? Where's the traffic going to and coming from? Looking at it by source network or interface to interface, again, in a data center, in a backbone, really many different slices of the network that you can look at for this. Looking at, you may pick a network and say, what interface is it coming in on? What have the BGP paths been to for that? So very deep operational tool and even some business applications of this kind of data. Looking by AS path, seeing AS path change over time on a router, on a customer. So a customer comes to you and says, hey, I want to upgrade my 10 gig. You can at least get an idea of where they're sending traffic to, how much it costs you. Again, it might, instead of AS path, it might be communities that you might pull that report on. DDoS detection, very common to be looking at Flow. SFlow, again, better, because with NetFlow, the router will be chunking for 10 to 60 seconds typically, and a lot of customers are looking to get detected pretty quickly. We've all probably been in the case where a customer, in the provider world, it's not even as much the customer being attacked, but all their neighbors. So a lot of providers want to be in the position of knowing before customers call the knock that there's an issue in a POP. And again, SFlow can give you that visibility a little bit better, a little bit faster. Or even looking at, in some of the modern tools, looking at traffic flows coming from routers, going through other devices and ASs and geographies. So again, very traffic engineering, and sometimes on the business intelligence side, from people trying to figure out why am I investing in the network, where should I be investing and growing to. So those are the things that I would call classic uses of flow, pretty well understood. We've been struggling with getting non-sucky tools to do this for 20 years. We're making progress. But there are other sources of data that are, I'd say, flow-like, in the sense that some of them can be carried over IPFix and NetFlow v9 templates. They actually are flow. But the kinds of analytics you're doing with it, instead of grouping by geography or destination AS or throughput, you might want to look at latency, application or server latency, even get into, instead of looking at AS path, you might look at URL. So things that people try to do with Splunk. Has anyone played with Splunk for anything? Anyone done a cost calculation on what it would cost to put NetFlow data into Splunk raw? A lot. Has anyone done Splunk as an aggregator for, sort of take summaries out of NFDump or Silk or something? We've seen people do that. So you typically think of syslog or weblogs as something that you have to go off into a logging system, but a lot of the flow tools actually present data in an aggregation that's very familiar with how you think about the network, and you can actually take some of those sources of data and put them into flow tools, and we'll talk a little bit about that. So what kind of data would you like to get? Well, the baseline I always come back to is, how is the network performing? Because this is, there was a recent NANOG thread about putting pinging boxes and estimating bandwidth. This has been something that, again, we've been struggling with for a long time. So sort of think of it as semantics, which is what is the traffic, more than just port, but URL, DNS query, SQL query, what is it inside the session? Application performance, which is what is the user seeing? Network performance, which is round trip time, loss, jitter, session setup latency, metrics that you can get, often passively. The devices that are running the traffic, think of a load balancer that's already unpacking the traffic, can export that information, and then you can aggregate it the same way that you're used to thinking about network data. These sources of data are available and can be used in flow tools to give you an interesting operational view, to alert on for what if, or just what should I do about the network. Same basic reports, just triggering on or grouping by a different thing. And some of this data is already exported in the protocols that the tools speak. So to give you an idea of where you can get this data from, you can get it from open source sensors. So you can span or tap, generally recommending span because tap because span can be very destructive to switch buffers when you do that. And you can run software that you can run on a Linux machine, on a hypervisor, or on a capture card equipped sensor that will give you the data that we were just talking about, the application layer data and the network layer data and the application performance data. So nprobe, Argus, both open source. nprobe has a commercial license too for some of the decoders. There's commercial sensors. Again, NTOP takes nprobe and sells a sensor, npulse and some others that you can put in on a tap or a span. Often this comes into the security group, but that same sensor can run augmented flow analytics that you can get the data from to look at the health of the network. Packet brokers, how many people have an Ixia, Gigamon, something like that, in data center? Usually those things run on taps where there's high value traffic or for security. Some of these devices can export flow today, and some of those vendors are looking at maybe doing some of this augmented flow. Some of the issues with them are that right now, some of those vendors only export unsampled flow. So that can be very stressful for a lot of flow tools that try to store everything and can't do rate limiting. Two other sources that I'd like to get you thinking about are IDS, bro logs. How many people run bro, Suricata, Snort somewhere in their enterprise for customers? So those are already looking at packets and grabbing IP addresses, protocol, port numbers, URLs, header information, generally not looking at the performance layer, but looking at the semantics. So if you already have parts of the network that are instrumented, you can get visibility by taking that data and making it look like flow. Web servers, so we see this a lot working with CDNs, web companies. Imagine you've got a server that you want to monitor flow on. Well, you could start looking at things like retransmits by running nprobe or Argus, but that has to look at the PCAP all the way up to reconstruct what the state was. But if you have a web server that can reach into the TCP infrastruct and get round trip time and jitter and loss and those network layer metrics, and already has the URL because it's already running as a proxy, you've got basically all the flow data plus a little bit extra, and I'll show you from Nginx logs how that works. Load balancers, Citrix does export, A10's working on this, so different vendors can generate flow that's got some of these templates in it that let you look at the performance layer. And Cisco has a big push with the AVC, which actually can run on ASRs, and you can grab traffic and say, now I want you to instrument this and generate this kind of augmented flow with real performance information, application decode, VoIP data. So a lot of interesting sources out there. I'll talk about a few of them and give you some pointers in this presentation to links about where you can read this. And most of these devices can export IPFix or NetFlow v9, so you can map those templates into your flow tool. Web logs and some of the security logs, you'd actually have to do some translation. And we'll be releasing some software that will take those kinds of logs, put them into a flow format I'll talk about, but then let you re-export those to IPFix, NetFlow, v9, take them into your flow tools. Again, as you think about flow tools, there are a lot of tools do let you say, here are some templates, and I'll show you what that looks like in some configs. And now take that into the tool, call it this, and let me slice and dice. Some don't. So if some of this becomes interesting, you should probably think about that as you plan what flow tools to get. So I'll give you an example, Cisco AVC. So this is just looking at a template, and there's a URL here that shows you configuring. It shows you some of the templates. They've got round trip time. You know, these are additional templates that would go on top of the normal flow record. They'll often have QoS tags, jitter, various counters that you can set, and so you'll get the normal flow and you'll get these templates. Now normally what would happen is the device could be exporting these and the flow tool won't know how to map it, so it'll just drop it. So actually usually it won't cause any harm to configure this, but to actually take these and map them to something is something you need to look at in this specific flow tool. And so imagine you've got a backbone running. How many people use ASRs for data center gateway, for backbone, customer aggregation? So if you've got ASRs and you configure this, and of course the big wild card with any new feature, and it doesn't crash your network or your device or whatever, right? So then you could actually potentially be getting live instrumentation rather than just pinging, or in addition to a bricks type setup, you can actually get what the router thinks the performance is. Citrix, if you've ever used a NetScaler, has something called AppFlow. Again, some URLs in the presentation, and they have RTT and HTTP data that you can get from it. NTOP, which is has nprobe, has templates, and you can see they've got enterprise. They've basically got well-known in IPFix. They've got an ID for NTOP, and then different identifiers that you can grab for what retransmitted packets is, geography, application latency, and again, map that into your system, and now you can do some interesting things. So, for example, nprobe can be used on a server watching PCAP, on a hypervisor attached to bridges, or again, on a sensor. Cisco has a product or a project, I guess, open source called OpenSock, where they've actually integrated nprobe with the HTTP decoder, and it's free. So normally there's a commercial license, but it's a big data stack, but it also has nprobe. So again, if you tap, span, put it on, you can get some of that data. Nginx logs, bro logs, there's configurables that you can do in the Nginx tuning to actually export TCP round trip time and congestion windows. And again, if you can map that into flow, now you've got more instrumentation about the actual health or performance of the network. So how do you store this? The data backend needs to be able to understand it and build some mapping. By default, you're not going to hurt anything generally turning things on. Flow tools will just drop templates they don't understand. But you do need to do a little mapping. Often people will put this into the backend, do some backend CLI or API scripting, then work on getting it into the portal once they establish these interesting use cases that are interesting for debugging or detecting issues. And what we see working with people, again, less on the provider side, but more on the web enterprise is the holy grail is what's the application performance? Is there something that's affecting a user? And if so, where is it? What is the cause between the network layer, the host, what's going on inside the servers that are running it or the virtual machines, and the application, maybe even with instrumentation, a New Relic type thing. And we've seen a lot of your customers that actually want to be very constructive, and a lot of them have RUM. They've got better data than we do as operators about JavaScript instrumentation of what the performance is from here to there. But the tools to date haven't really helped the people that run the websites to see what the network is doing. And so a lot of this comes down to not only monitoring, but also just reducing time when there's a user problem and people have to point and say, is it a network issue? So that's where we see things going. We've even seen some providers that are able to get data from their customers that can do this instrumentation. But of course, then the sort of the promise is that you'll be a little bit responsive to that, which is always dangerous because explaining to things that the internet really is, best efforts can sometimes be tricky. So one back-end storage system I'll point to, which actually there's a flow tool called, is anyone using ipfixcall? Comes out of the Czechoslovakian NIC. They did a fastbit-based NetFlow tool. There's fastbit is an indexing library. Luca for nprobe had used this a few years back, which is where we had seen it. And he's got CLI and some tools that you can use that actually wind up turning the flow storage into SQL queryable, or in some of these tools, SQL-like queryability, so you can do very flexible slice and dice. And it's a column store format that lets you store the attributes in just separate columns, and then you've got a SQL mapping up front. So very easy to expand. You'll have IPv4 address, IPv6 address, geography. But if you want to map a template and create app latency, then that becomes something you can query. And again, some of the other tools allow you to do this. If you're writing your own in big data platforms, it's generally even easier. You'll need to, if you use PM account, you need to write a decoder and build that gateway. So 3 use cases I'll talk about, get you thinking. Network performance. This is, I think, where a lot of people that we work with start. This is the first thing I did when I was building a flow tool, was pick a metric, because you don't want to make it too complex, and it could be packet loss if you can measure that, TCP retransmit, which is what a lot of the web operators look at, RTT, and add that to your flow reporting so that you can do the same kind of slicing and dicing that we talked about before, but organized by percent retransmit. One thing I'll say is if you're doing retransmits, packet loss, you don't necessarily you want to have a little bit of weighting, because you may have a really long session that had as an absolute number the most retransmits, especially as TCP is ramping. You'll have things that look like retransmits, and you really do want to wait when you do this kind of reporting. In systems based on fastbit, if you're already building SQL queries, you just add a column and then you just change the query a little bit. And before we looked at traffic by destination AS. Instead, if you've got the data in a tool, you can look at percent retransmit by destination AS. Or a common one is second hop AS. So not necessarily my transit provider, but the one right beyond, or the entire AS path. So if people want to do and I'll go back into the history of the archives and try to make Dan Golding twitch, Sockeye, Route Science, NetVMG, one of those type things. Where do you get the data to drive that? Well, rather than pinging, if you can actually get it from the infrastructure, that's pretty cool. Another thing that you can do that we've seen people actually do with this kind of data is look at application level attacks. Now, you may have some privacy concerns if you start grabbing URLs out of the network layer. Where do you store that? Who has access to it? But you can begin to see, especially if you think you're a hosting provider, what's going on in the infrastructure, where are people actually attacking, and a lot of the people that we're working with on this, it's not their servers they're protecting, they're looking at the user behavior to see what kind of traffic are they generating, what kind of requests are they generating. When they've got a forensic thing, they need to go in and look at that. And again, if you organize that in the same place as your NetFlow, you can potentially converge the back end, especially in a big data architecture, save a lot of money. Another is APM, what we call APM Lite. That first use case that I talked about, which is show me, don't tell me there's don't tell me there's a network problem if there's no user affecting problem. But if there is, try to do some correlation and show me where to look. And again, if you have the data in there, you can start building the queries. So for example, API performance debugging, something that we've seen people do. And blast bot detection. And you've heard a lot about DDoS at NANOG. This is more on the e-commerce bot side. Again, looking at what your hosting customers are doing. If you're a web property, who is giving me requests that are not quite natural. Now you can do this based on syslogs, but it turns out that having the AS-based view on top of the weblog data with a little bit of the timing information that can give you an indication of whether it's a user or a bot is a very interesting way to slice and dice and help you see in a different way than Splunk or just Elasticsearch on some of the same data. So we're going to be putting out some tools on our GitHub that actually let you take weblogs, brologs, some of these other augmented sources will break down those templates, so we're doing the homework, and turn it into a flow export type that we're creating called Kflow, which, how many people have looked at the NetFlow v5 specification ever? Just a C struct. So think of a modern C struct, something called cap and proto. Ever heard of protobufs? Anybody? So it's the guy that did protobufs said, I want something really fast. So created cap and proto. And it's just a way to serialize or put into a transport format different protocols. And so basically it's a superset of all of these augments that map in, and then we're going to have some tools so that you can take some of this data and then put it into this format and put it out into IPFix v9 and put it into your standard flow tools. And so what it looks like, it's there's Go bindings, C bindings, Perl bindings, and then it's pretty easy to write code around it. So I just wanted to, in 30 minutes with 32 slides, I just wanted to tease you a little bit, get you thinking about talking to vendors about this. We've talked to some other vendors than Cisco that have said, yeah, we're sort of hearing buzz. There's things we could do on the ASICs. Would it be interesting? But we don't hear the community saying, oh yeah, we'd love to have performance information, instrumentation at the flow layer. So I would encourage you to talk to your vendors about it. And I think we have 2 minutes for questions. Flames or comments? Mr. Dobbins.
Okay, got it. Right.
I can project, or is it working now? Okay, great. Yeah, great presentation, lots of good information. Just wanted to clarify a couple of points. The 1 minute thing about flow telemetry as it's implemented in most platforms is actually a myth. The speed of detection, classification, and traceback via flow telemetry is actually affected by a combination of the active flow timer setting, the inactive flow timer setting, as well as the actual state size and state of the flow cache in a given exporter. There's a high degree of variability there. The 1 minute thing is, people talk about the 1 minute thing because a typical value that an operator would set for the active flow timer would be a 60 seconds. That's actually a maximal value, not a minimal value. So the active flow timer is the ultimate arbitrator of the maximum time to export flow telemetry that could result in detection, classification, and traceback. And with regards to a lot of the richer flow telemetry options and formats that you brought attention to, One of the problems has been until very recently, while, first of all, Cisco Flexible NetFlow, which you can blame me for the CLI for that, if you like. I worked on that when I was at Cisco. The problem is that there are a lot of different additional fields that could be exported, but the vendors didn't provide a standardized control plane interface for dynamically building and tearing down flow caches that would have these different, key and non-key fields. And I hate to say it, but the dreaded SDN is finally actually providing some standardized interfaces for that. And so I think a lot of the open source tool vendors as well as commercial tool vendors will be able to finally start taking advantage of some of these richer flow formats that you did a great job of explaining, quite some time after they've been introduced, but better late than never. Thank you.
We are in violent agreement. I've said we're in agreement. Yeah. At some point, we'll probably do a flow tutorial and get into the inner ickiness of configuring all the flow timers, but and probably have a subsection on how to make your 3BXLs be semi-useful for this. But yeah.
Any other questions?
Okay.
So thank you, Avi, and thank you, Roland, for that extra mini presentation there.